Okay, let's talk a little bit about iteration, or practice makes better. Iteration is basically the act of repeating a process with the aim of approaching a desired goal, target, or result. Each repetition of the process is also called an iteration, and the results of one iteration are used as a starting point for the next iteration. Basically, an iterative process is one that's building on itself. You care about what happened before to figure out the next step. We see iteration in a lot of different places. A lot of computer programs are designed iteratively, or computer programs run iteratively. They build one step onto the next. And in our case, kind of product design and the engineering process itself tends to be an iterative design, where you take an idea, you solicit feedback, you build on the idea, you test the idea, you solicit feedback, you test the idea, you refine the idea, you solicit feedback, and you just kind of keep going in these neat little circles. One of the kind of tenets of this, and the thing that drives people a little crazy oftentimes, is that there's no necessarily right answer to this. Well, it doesn't have to be. Sometimes there is, but for most of these processes, it's a question of just getting to the next step, getting to a better version of it. The best version, or some idealized version, is not always possible. So in practice, we can think about this in terms of, papers you might write, or for the seniors, perhaps college essays. You have a process here. You have some pretty good ideas, or maybe terrible ones. Leads to maybe an okay idea, a good one. Maybe you get one that your mother really likes. Perhaps one comes from some bizarre circumstances. And then after you do this a couple times, you get somewhere to something that you might actually consider possibly turning in under some circumstances, such as it being due in 20 minutes. There are always going to be limitations on this process. Some of them artificial. You have a limited time, you have limited resources, you have limited money. Some of them, I guess those aren't really artificial, but some of them external, some of them internal. Maybe there's only so good you can do. Now, in engineering and product design, really this whole loop that we're talking about here, this engineering design process, is basically an iterative thing. But what we specifically want to think about is this closed loop over here, kind of building a prototype, testing it, talking about it, redesigning it, coming back and going into here. So you already have an idea. You know what you want to build. And the question is, how do you build the best thing you could build? You're not going back and saying, oh, never mind, now I want to make an ice cream, scoop, when before you're trying to build a nuclear submarine. This is not going back to the drawing board. This is going back to a drawing board, maybe. It's not scrapping the whole project. It's just trying to figure out what the best thing to do is. But then the whole loop, the whole process really is iterative. Where maybe once you've got a design, maybe now you want to make another one. Maybe you want to make a new iPhone. You want to make a new ice cream scoop. You want to make Windows 10. And you got to go figure out, all right, so what was wrong with the old Windows? What was wrong with the old ice cream scoop? What was wrong with the old nuclear submarine? And in that sense, it's still an iterative process. You're taking feedback from the last generation and pushing it forward. So now we want to kind of think of what goes into making changes here. When you do decide to iterate, whether it is kind of in the process of trying to decide on a solution or in terms of starting up a new project, the kind of things you want to think about, are timing. Like, how long do you have to do this? What's an appropriate time frame? If Apple released a new iPhone every month, people would probably stop buying them eventually. Maybe. Might not be the best example. Sometimes, a new design is brought about because of technological advances. You have this new thing you can present. You can do it cheaper. Maybe cost is a factor. You can do it faster. You can convince people that bigger numbers are a better thing. They should pay more money for it. Perhaps your consumers didn't like something about it. Your users decided, an ice cream scoop that accidentally sets you on fire is not an ideal product. It's something you should figure out to fix in the 2.0 version of it. Sometimes, you have this great thing, you have this brand new idea, it's an ice cream scoop and it plays MP3s, and bam, this is innovation that the masses need to have. It will change their life forever. And sometimes you have innovation that is perhaps not really so innovative. It's an ice cream scoop that also works on Jell-O. Bam, mind blown. Or not. If we want to look and see kind of examples of this, we can see, if we look, cars are a good example of this. Every year, you tend to see a new version of a car, and you can see, as year goes by, what features come, what features go. There's a time when air conditioning was not a thing in cars. It was, it was a fancy thing. It was a big deal to have a car with an AC. Now, I really don't think there are cars that don't have ACs that are made anymore. Certainly not things that I would want to drive in particularly. But I mean, there was a time when an 8 deck was a thing, then a cassette deck, then, a CD player, and that was really never the best thing that they put into a car. Never mind the fact the actual car itself, probably the engine and safety features, not just, the electronic systems. But looking through some of these, you can see examples of things that were well received, things that were poorly received, times when cars were popular, not popular. And this is the kind of stuff you want to think about for your products, for your project, for the presentation due at the end of this week. So, iteration. That's all I got to say about that. Good luck.